today we present unsupervised scene sketch to photosynthesis. So we look at the task of sketch-based scene generation. So for example, we have a scene sketch of mountains on the left. They can be of different shape, or they might have different components or objects in this scene. For example, you have pines, you have mountains, right? And then our goal is to synthesize photo that looks realistic and it has similar shape as a given sketch, as shown here. The problem for this task is that it's ill-posed because for sketch you really don't have texture or color. So what we want to have is give a style reference to this sketch input, so you know how to generate the color and texture to put there. And then you could have a synthesized photo. The style and texture looks like your style reference, and the shape looks like your sketch. Another thing what we do is we could have sketch-based scene edit. So if you give a photo to your system, our system first generates a synthesis sketch, and then you could modify the sketch because strokes are easy to change and modify. You could add a lamp and then remove this blanket. And finally, you can generate back a target photo or edited photo that has all these additions. You can even change the style based on the previous talked about the system. So how existing work does this? They are heavily influenced by this ECCVW paper called Sketchy Scene, where different objects of the sketch are combined to render a fake scene sketch. So the solution is really try to break the sketch into objects and then synthesize for each part and finally combine them together. This CVPR20 work is exactly doing this. They first do a segmentation on the sketch, and then synthesize the image of each object and then combine them together. The issue is, the quality may not be very high because, for one, you have to, it's a cascaded process, right? You have to, segment the first, so there might be some errors, and then, the combining may also cause you a problem. And what we do is we directly learning from photos rather than, break them into different parts. We directly, learn from this whole thing sketch and then generate a synthesized image. And the main takeaway is by this way, the holistic scene structure can be preserved and we don't, broken them into pieces. So exactly how we do this. So first we do a standardization. So for training, we grab a bunch of scene images, and then we do edge detection to estimate the edge from it. And then similar thing, we do for inference. Also, we generate the edge, from the sketch. So in a way, by standardization, it means it gives you like a similar appearance. Standardize the input to the next stage, which is the photosynthesis stage. Basically, take this standardized edge in, and then take a reference image in, and then finally it synthesize the photo. So there are two good things about this pipeline. First is that by standardization, we make sure the gap between training and test is minimized. Another thing is we use the edge of the photo, so we can use abundant readily available data sets. Here is just a training pipeline of the different stages. So first we learn this kind of like disentangle content and style representations by auto-encoding. And because we know the correspondence between image and the scene, we ask a content consistent loss between the two representation. And finally, we just fine tune, with this unpaired data, which has sketch reference, and then finally we synthesize the photo. So here are some results of the room sketches, church sketches, and the mountain sketches. Specifically for mountain, we show application where we could interpret different styles. We could combine the styles from winter and summer, and then gradually go from one to another, or we can go from afternoon to dusk. You can look at more details in the paper. Here, just a result of scene editing. We can gradually add some objects into the sketch and render images gradually. Finally, how we evaluate the system, we did a perceptual study. So we ask if we can generate photos that really fool people. So we ask people which one is the real photo, and then calculate the the fooling rate. So you can see for mountain, the fooling rate is around 50%.